Hi everyone, welcome back to Basic for Beginners. Today we will discuss logistic regression. Logistic regression is used when input or independent variable is quantitative, whereas output or say dependent variable only has two values like 0 and 1, true and false, male and female, yes and no, etc. For easy calculation, output or dependent variable is converted to 0 and 1. Its graph cannot be explained by linear model because of the S-shaped curve. Therefore, instead of taking the actual values of the output dependent variable y, we take probability of y. And the curve is explained by the following equation. So how do we perform logistic regression in R? In the previous video, we used LM function for linear regression. Here we will use GLM function for logistic regression. GLM is short for generalized linear model. GLM function also has columns mentioned in the first argument and dataset in the second argument, but it also has a third argument named family. Family by default has value Gaussian, that is used for normal distribution. So if I use GLM function for linear regression, it will give the same results as of LM function. But family also can have another value, namely binomial, which applies for logistic regression. For logistic regression, I will give the column Vs that has two values 0 and 1 in GLM function and run this. It will give me the following results. As in linear regression, the first row is for intercept and second row is for coefficient of x, which in our case is DISP. First column gives the value of both, second the standard error, third the z value, and fourth the p value of the z value. Additionally, we have three more values: null deviance, residual deviance, and AIC. In brief, null deviance is the deviation from the model if only intercept is taken into account and there are no input variables. Residual deviance is the deviance of the observed value from the model. AIC is a metric that estimates the fitting of the model. I won't go in depth for the three, but remember they have to be low for a model with good fit. Moreover, one can calculate chi-square statistic by calculating the difference between null and residual deviance and use the number of predictor, input variable, or independent variable as degrees of freedom. Here, the difference would be 21.164, which is more than the chi-square value for 0.05 alpha level. Therefore, the result is significant. Now, you can also use the predict function as in linear regression with new DISP data. But remember, these values are not actual values, but the probabilities of getting the value of Vs to be 1. So that's it for today. Thanks for watching. If you learned something from the video, please like, share and subscribe the channel.